This is a robot, and although it may be built from a child's toy, it is completely programmable, controllable, and if I add more sensors, it can become a lot more independent. But this robot has one major flaw. You see, I built it, and for that reason alone, I cannot for the life of me figure out how to control it.
This does work, and what's more, it works underwater. It's a blend of watertight metal boxes, fiber optic cables, and other high-tech gadgetry. It's a research platform for York's Centre for Vision Research. Leading the team is Michael Jenkin. He, along with Andrew Spears, James Zacher, and his son Isaac, are part of a larger team which work on the robot.
So the robot you saw was Croy. It's an amphibious robot. It's designed to work, you saw it operating underwater, but we have other legs that work terrestrially, and legs that actually work terrestrially and in the water. And so that's a research platform. So it's here the primary goal is to understand how to make a device like that see, how to make it move, how to make it interact with its environment. But that particular device, or its cousins if you like, have been used from everything from environmental investigation, that is how is a reef decaying over time, to assisting in aquaculture. So it has a wide range of applications, but here the primary interest is research.
The robot is controlled by one of the divers from a submersible box that is tethered via fiber optic cable. This allows the robot to go into areas that may not be safe for researchers. The current unit is available on the market for purchase, but Michael and his team are using this one to test hardware and software for other applications.
So to give you an example, if you have a robot that works on the ground, it works in a plane. And so that's a two-dimensional problem. You have an X and a Y and a rotation. That's all you have. But underwater, you have an X, Y, Z problem, and then the vehicle can roll, pitch, and yaw. It can move in three orientation directions. And so that gives you sort of a problem that had three variables to it, to one that has six. And that makes it a much more difficult problem. Also, if you have a terrestrial vehicle, you can sometimes cheat, right? You can use GPS to figure out where you are. You can use the horizon as a visual cue for where you are, and so on. Underwater, that's not so true. Also, a terrestrial vehicle, you can use gravity to tell you things like, is the vehicle on the ground, is the ground tilted? Underwater, that's not so useful because your vehicle could be in almost any orientation. It's still a valid orientation for the vehicle.
The research is also part of students' education, and this is funded in part by organizations like the Canadian Space Agency and NASA.
One of the reasons that, for example, space agencies are interested in the robot is the kind of questions that you ask underwater are the same kind of questions that a free-flying space robot would have. But it's much cheaper to do the work underwater than it is to do the work in outer space. So it's it's an interesting place for them to ask questions and to get answers to questions, which they can then apply to problems in outer space.